The objectives of this video are to understand how the Arduino printed values relate to the input voltage, and then we're going to graph this data and we're going to analyze it, and then we're going to try to analyze it using Data Streamer, which is a Microsoft Excel add-in, and that can assist with our data analysis. Those are the goals of this lesson, but you're going to use the same materials that you utilized for lesson number 4. So if you haven't done so already, go look at the breadboard and the circuit diagram, as well as download the code so that way you're ready to go for this lesson. I have pulled up the code. It has already been uploaded, but we'll go ahead and upload it again to make sure the correct code is running. And then we are going to use our serial monitor and we are going to watch the data populate. What I want you to do is I want you to let it get some numbers, and then I want you to put your finger over it. Maybe get like 5, 10 data points, and then let go of the resistor and let it collect some more in the light setting. And do this about 10 times where you're like 10 seconds on, 10 seconds off, 10 seconds on, 10 seconds off. We need to just collect a whole bunch of data. While you're doing that, I want you to put show timestamp just so you can see what that does. And notice that's all it does there, is it's going to show the timestamp. Okay, I'm going to clear my output just so we can start over. I don't need the timestamp, but if you wanted the timestamp, that's all you could do there. The auto scroll, notice all the auto scroll does is it stops the scrolling where it's at, so then you have to scroll up and down. So I'm going to clear my output, let it reinitialize. So I'm going to clear my output, and then I'm going to close it, and then I'm going to reopen it just so you can have those headers again. So about 10 data points with the light and 10 data points in the dark. And then keep repeating this until you have about 10 different data points for each the dark and the light. All right, so now I have about 10 on and off states. So I'm going to stop my auto scrolling, and then I'm going to select this data and copy it over into Excel. So I'm just going to hit Control C, open up a new Excel spreadsheet, and then paste it. Now notice it pasted all into one cell. We don't want that. So we need to go to Data, Text to Columns. It's going to be delimited. It's going to be delimited by a comma. And then we hit Finish. And now it has separated them all into different values. So we could just graph these, but these light values, what does that mean? Okay, this is where you have to think about your voltages. So my input voltage is that of 5 volts. So I'm going to type that in, 5 volts. The way it works is for our analog inputs, there are 2 to the 10 values or integers that we can assign. And so the analog read function is an Arduino function that's going to convert those input voltages into integer values. And like I said before, there are 2 to the 10th integer values that can be assigned. And so we can assign anywhere from 0 to 1023 because that would give us 1024 integer values. And so what we're going to do is the difference between any integer is going to depend upon whether you're using a 5 volts or a 3.3 volts. So I'm going to do both of these as an example. So say instead you are running the 3.3 voltages of your Arduino, how would that change? So let me do equals this value 5 divided by 1024 because that's how many values I have possible. And then I'm going to drag it down. And so you can see that for a 5 volt, each integer value is 0.0049 different from the next one as far as voltages go. So if 288 and 287, how different are they as far as voltage goes? There's only a difference of 0.004883 voltage difference between those two values. And so if you're wondering what are the differences, it would be these two values here. And so once again, 1024 is just because that's how many integer values are assigned for the total voltage differential of the circuit. Okay, so now I want to make a new column because it's not as helpful to do light value because your light value is going to be dependent on your input voltage. And so what I'm going to do instead is I'm going to make a new column for voltage. We are going to take the light value now and multiply it by that 5-volt value, which is going to be like a conversion factor now for us. And then I'm going to use function F4 on this F1 because I'm going to drag the cell down and I don't want to lose the 1 because I want all of these cells to be relative to 1. So I want them all to be F1. And so that $ says hold the F constant, and the $ in front of the 1 says hold the row constant. And so if you'll notice, even though I drag down each of my cells, the formula matches exactly in every single cell. Now that we've done that, we need to graph our two axes. So we want to graph our time column versus our voltage column, and I just used Control and Shift and then down arrow in order to select all these pretty quickly. And now we can go and we can insert a scatter plot, but we wanted to choose a smooth plot. And so now we can see all of our data values here, where we can see our light on states, which are high voltages around 1.4, and our low voltages where we had an increased resistance from the light being off. So notice how they're right around 1.4, and then those bottom values are around 0.4 or so. Now let's just do a couple things to make our graph look prettier. Let's put a title in there. Let's add some axes, change those axes titles to be time and voltage, make all the text black. Let's give some little tick marks there. Let's make it prettier. Now that we've done that, let's have an average voltage for our high states and an average for our low states, where the high is that light on and then the low is that light off. So we're going to find the average of these values. Sure, we could just go equals average and select all the big values, but that would take a long time and a lot of attention to detail. Instead, we can use an average if function. We have average if, and then we select our values, where our condition is greater than 1. So using this formula, it's going to return all the average of all of those values that are greater than 1. And yes, sure, like I said before, you could go pick it out, or you could use the if function to do this. And so this function is taking the average of all of those high values. Let's look a little bit more at the formula. So you can see the blue is all of those voltage cells, and then where it says greater than 1, that's going to be our criteria. So we've got our range and then our criteria. Now we're going to want to do the same formula for average of low. So I'm just going to copy my formula and then replace my greater than 1 with less than 1. So I'm going to change that to a less than symbol. And now you can see my values, where the average high is about 1.42, but obviously we don't need all those decimals. And then we have our average low is about 0.58. And so that allows us to quickly find the values that we need on our graph. The next thing I want us to do is to utilize Data Streamer. Now, it would be really nice to automate that graph that we saw, just like the software on our normal instruments will do for us. And so Data Streamer is like that. It is an add-in in Excel that can take the Arduino's raw data and it can graph it, or at least collect the raw data stream for us. And so that is Data Streamer. And you can follow these directions here, where it's enable the Data Streamer add-on. Both of these links will be below the video. So if we go to Excel, we basically need to go to our account options, add-ins. So you can see here that this Microsoft Data Streamer for Excel, it is inactive on mine. So if I come down here to manage, and then I manage these COM add-ins and hit go, then I can choose Microsoft Data Streamer for Excel and hit OK. And it's going to activate that Data Streamer tab, which you see along the top. So now I can come up here to connect a device, and it was COM7, I thought. Yes, COM7. And now you can see it. So let's hit Start Data and see what happens. So we have current data. There we go. Now it's starting to populate. Now this is the weird part I don't really like. It starts at the bottom with the newest, and then it has the timestamp on it, and then you can see the reading here. But still, the same thing is true, whereas if I put my finger over the photo resistor, the values are going to change and it's going to collect it. And so here is just a way for you to utilize the screen capture, or the stream capture, excuse me, while doing live data collection. So it puts it directly inside of your Excel. Now, what can we do with this? Let me stop data. You can see this is all of my data in. This is for any data out. We haven't actually sent any data to the device. This is controlling some of that orientation. So if we didn't like the newest, we could also do newest first. Okay, so that's changed to 1,000, but then data rows, number of historical data rows to keep. I'm gonna need a lot more than that. So I'm gonna change that to how about like 1,500, so like 1,500 seconds. I'm not gonna be there this long. So if I start my data now, again, I have my newest first. I have 2 time channels. I have a bazillion places for those historical data. And so now if I were to stop it, I already have my data inside of my rows. And so that's just one way where that might be helpful. And you can already have your graph set up if you wanted, so it can display here. And so it's just a whole matter of what works best for you, importing it after the run or during the run. I'm going to stop data and show you how this could be helpful for having a graph. So I'm going to go back to my other Excel spreadsheet that I've already made this chart on, and I'm going to copy it and I'm going to paste it into this Excel spreadsheet just so I don't have to remake it all again. But now I need to select my data. And so I want to edit those data and I want to give it a new name. My X values are going to be located in this spreadsheet now. And so my X values are time, so that is this channel. And then my Y values are my photoresistor, values here. And then I hit OK and OK. So I copied this graph in and I've already kind of showed you how to change those values, but I want to make it be a future value. So maybe I want to go to 3,880 or something like that. Then I would make it go to that and then I would hit OK and then OK. And the benefit of this is if you scroll down, notice even though my values stopped, my graphing did not. And so now I can click off of the chart, hit Start Data, and my graph is going to automatically change based on what my values are. And so I put my finger over it, it's dark, I let go of my finger, and it's going to be light, dark, light. You get the idea. But now this is something that is happening in real time. You can also, if you wanted to, make your separate column next to channel 2. And so maybe that this channel is going to be my voltage instead of my light values. So equals that value times my conversion factor. And then drag that down. The important thing is I need to drag it down for a very, 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 very long time, or else it will not automatically populate it. So I dragged it down for a long time. Let's come back up to the top. And now we're going to change that value. So instead of being within the C row, let's change it to be this voltage row. Hit enter. And now let's hit play. And so you can see once again, it's getting populated in real time. It made that giant jump because some time had passed. And now dark state and light state. So you're getting a graph in real time, and that's the main advantage of the data streamer. There's some really pretty things that you can do with this and set it up to make it look really nice for the end user. So basically, if the end user is someone who needs stuff to be very simple, like maybe a high school chemistry class, then this is a fantastic way for them to use the Arduino software. But if it's someone that knows how to analyze raw data, you may be interested in the raw data so you don't miss values when you've stopped data streaming.